So as we just discussed, remember that arrays are objects. So this might be starting to sound a little like a broken record, but it's very important. What's stored in memory in the location of a name of an array is a reference or memory location or pointer to somewhere else where the full array is stored. So remember what that means about using direct assignment. So let's say, for example, you wanted to make a copy of an array so that you could have two different variables, having the same information. Well, you could declare nums1 like this, and what a lot of people, their instinct to do is to say, well, nums2 gets nums1. But let's take a look at what happens in the code. So if this is what we have with nums1, where it points to an array that holds 5 numbers, like this, and if we'd like to think that nums2, if we assign it to nums1, would get the same thing, but that is not the case. No, no, no. Okay? So remember that with simple assignment, we take the value on the right and we put it in the variable on the left. Well, what is the value of nums1? The value of nums1 is this memory location. So that's what gets stored in nums2, which means the picture looks like this. So nums1 and nums2 are actually aliases. They point to the exact same place in memory. So if we go back to the code, if we now have the line nums2 at 0 gets 99, that means nums2 at 0 gets changed to 99, but it's also changed for nums1 because nums1 and nums2 point to the exact same place in memory. So just doing a simple assignment like this will not make a copy of an array. It creates two variables that point to the exact same place in memory. So what this means is that if we want to make a copy of an array, we need to copy each element over into a whole new array. So we need to set up a new memory allocation of a new space in memory, and then we need to manually copy over all the contents from the old array into the new array. Okay, so one reason we might want to do this, well, actually, let's first just do it with this small example, and then we'll look at another reason more generally why we might want to do this. So let's look at array copy. Okay, so first we have our nums1. And we've just said that we cannot do this. This will not work. It creates an alias, so we don't want to do that. What we can do is we can create a whole new space in memory, so we can create a new integer array. And how big should it be? Well, if we want this to be a copy, it should be size 5, but we always want to avoid hard coding numbers into our code. So let's just say it's going to be nums1.length, meaning it's going to be the same size as num1. Then we have to manually copy every element over. So we have to go in from I equals 0, I is less than nums1.length, plus, and we have to say, okay, well, what I'm going to put at nums2 is going to be whatever it used to be at nums1 at that position. So nums2 at I is assigned the value of nums1 at I. So this, if we go back to our memory picture here, oops, well, I guess I don't have a memory picture that works for this, but it would take, 3 and would take that value of 3 and put it in nums2 at position 2. Now this only works obviously because these are primitives, so the actual value is stored there. You'd need to do a little bit more work to copy objects. I'm not going to go into that example here, but think a little bit about what you'd have to do and what this would look like if these arrays held objects instead of primitives. But in general, when you want to copy over an array, you have to create a whole new array and then manually go through and copy those contents. So one time you might want to do this is, again, remember that we can't make our arrays bigger. So there is no way for me to say, actually, I want this grouping here to actually hold 10 numbers instead of 5. I can't do that. Once I say that my array is size 5, that's the size. I can't change it. But what I can do, the kind of workaround for that, is I can create a new larger array, copy over the initial contents, and then make my reference point to that new bigger array. Okay, so that is what I can do. This is sort of our workaround so that in theory it sort of looks like our array is bigger, even though it's not that we're making the array bigger. We're creating a new array, copying over the contents, and then having that be our new reference. Okay, So let's say here we had our original array, and we now decide we need this to hold 5 elements. Well, now we create that bigger array to hold 5 things. We then copy over the contents of the old array into the new array, element by element. Remember, we can't just use simple assignment. But then what we do is we do use simple assignment to say, okay, we're now going to take nums and we're going to point it at this new place in memory, because this is where we actually want the new array to point to. Okay? So actually, let me pull up what that might look like. Okay, so again, we've got our nums array that looks like this, points to a 3-element array. Then in this line here, we create a new bigger but empty array, looks like this. So more nums holds 5 things. So there's our 5 elements that are empty. Then in our loop here, we go through and we say more nums at position I gets nums at position I, looping only up through nums.length. So we say more nums at 0 gets nums at 0. More nums at 1 gets nums at 1. More nums at 2 gets nums at 2, and then we're done. So you'll see that we still have some empty space here on the end of our new bigger array. And then we have an assignment statement. So here we take the value on the right, store it in the variable on the left. So what's the value on the right? What is the value of more nums? Well, it's this memory address. So that's what we store in nums. So now nums and more nums are aliases. This now allows nums to point to what looks like a bigger array. So this is how we can, again, make it seem like we've increased the size of our array. We actually haven't, right? This part here, this array here is still in memory. Although because nothing points to it now, it'll be automatically garbage collected. But it makes it seem like we've grown the size of nums, when actually we've created a new array, copied over the contents, and we now have this extra space that we needed. But again, the bottom line is there is no way to expand this group of memory that we allocated. All we can do is create a bigger sized array, copy over the contents, and then make our reference point at that new bigger array. So let's just practice doing that. We want to have an array that stores numbers from 1 to 100. So we'll say the small array is going to hold 100 numbers. Let's fill it up. Now, can we use an enhanced for loop to fill it up? No, we can't, because remember that we can't use an enhanced for loop to modify the element stored in an array. But we can just use a regular old for loop to say small array at I gets what? I plus 1. Okay, so now this will fill our array with the values 1 to 100. And let's say we have, other code that manipulates the array. And now let's say, we actually decide we need our array to hold more than just 100 elements. We need it to hold 200 elements. Well, we have to have a bigger array to do that. And then we'd copy over, so we declare a bigger array. Then we copy over the contents. And here's the important part here, right? We need this loop to go only up through small array.length, because that's the only part of the array that's going to be filled. Any positions that are greater than small array.length in the new bigger array, we want to leave empty, because that's where we're making kind of our new open space. So we can say bigger array at I get small array at I. So this will copy over all the contents, right? And then we say, okay, well now I actually want my small array to point to that new location in memory, which that new location in memory is located here at bigger array. Okay, then if we wanted to finish filling it up, we could start at well, we would have had to actually store, before we do this, let's store old small array size. So if we want to now continue filling that up, we will start at position old small array size. In our case, that'll be at position 100. Go well I is less than what the new length is. And we can continue filling in that way. Okay. So we can now see, we could print this out. We'll use our arrays.toString. Oops, what am I missing? I didn't import it. Of course, we need to do that. So we now can see we have all of our numbers up to 200. And of course, what would be printed if I printed out the bigger array? What do you think? It's going to be exactly the same thing. Why? Because those arrays are aliases. This line here created an alias. Small array and big array point to the exact same place in memory. So any changes we make to small array will affect bigger array because they're exactly the same object. So one last note here, we've talked a little bit about the arrays.toString method. So the arrays class, again, note that S is a class that Java provides to you, which has a lot of useful utilities. We've looked at the arrays.toString. There are also copy methods in that class. I'm not going to show you those, but you can look up the arrays API, take a look at the copy method and copies method, and it will gives you some help there. If you don't want to manually copy over an array, you can use the utility methods to do that. So remember, to find the API of any page, you can just Google Java, the name of the class, and then API. First link that comes up should be the API page for that. So take a look. There's lots of other good utilities in the arrays class. So one last note about arrays as objects. Remember what it means to pass around objects as parameters. So just like any other variable, we can pass a whole array as a parameter, but also just like any other variable that's an object, it means that what gets passed is the value, because Java is passed by value. But what the value of an array is a reference, a memory location, or a pointer to somewhere in memory where that array lives. So that means the formal and the actual parameters become aliases of each other. Okay, so that means that if you change an array element inside a method, that change affects the array outside the method because it's the same array, it's the same object. There's only one object that's being passed around. Okay, so we'll take a look at an example of that in a moment.